Okay, so folks, what we got here is a 2009 Acura TL. V6, all-wheel drive, luxury vehicle back in the day. Still pretty nice, even by modern standards. One thing that's not so nice is that it's got a V6 and it should have a 4-cylinder in here because there's like no room to work. But anyway, we'll manage. Here are the symptoms. The person that owns the car, it's a neighbor. They said, hey, won't start. Don't know why. So we got taking a look at it. The battery was dead. So we tried to charge up the battery just as a starting point, and my charger was saying fault. Couldn't charge the battery. So, first thought is, well, maybe the battery's bad. But I disconnected the battery from the car, negative terminal, and suddenly the battery could start taking a charge. So it's not the battery that's causing the battery charger to think there's a problem. Something else in the car. So I went in at the fuse panel area and started pulling a few fuses, just the major ones. This connector right here goes to the battery, and this connector right here goes to the alternator. When I undid that one, and then connected the negative terminal back to the battery, suddenly the car was able to charge the battery with it connected. I also took an ohm meter reading of here to here when this was disconnected, so I don't fry my ohm meter, and I was getting very low. I think it wasn't quite a dead short, but I think maybe 3 or 4 ohms, something like that, which would definitely drain the battery in a short time when the vehicle's not running. So, yep, so then I got into the state of, okay, let's charge this battery and forget about working on that, and let's chase this cable right here down to the alternator. So that cable is held on to the alternator positive stud right here. It's underneath this rubber boot, okay? So you gotta peel the rubber boot back. I think there's a 12mm nut that's on there. Unsurprisingly hard, actually, but it's probably original, and there's 250,000 kilometers on this vehicle. So anyway, pull that nut off and pull that cable off, and then I could reconnect it at the fuse panel and still charge the battery. And it really proves that the alternator was the problem of this fault. Now, I've done some checking of resistance, and I'm gonna show you this on the bench after I get the alternator out. To get the bottom bolt out, I took the shroud out, I sprayed some penetrating fluid at the bottom bolt at this angle, and then I was able to use a 6-sided socket with a 3/8 ratchet. I don't have a breaker bar, but anyway, used a ratchet with this on the top of it for leverage. And so there you can see my ratchet operating like that. The trick I want to show you though that makes this job much easier is, I don't know how the pros do it, but normally you want to be able to get at all the bolts direct on so you can get a 6-sided socket on there. In this case, the tensioner pulley was in the way of the bottom bolt. So how do we get the tensioner pulley out of the way? Well, you got to take the tensioner pulley and stretch it so that, or load up the spring so you can get the belt off the alternator anyway. But after you do that, when you let go of the tensioner pulley, it slides right in the way of the bolt that you're trying to extract. So what I have is a 14mm wrench on that tensioner pulley bolt, and then I have the wrench extender right here. And then there's another wrench, and you'll notice I've got it tied back this way. So this is a ratchet strap wrapped around that cross member right there. And it's coming to the wrench and pulling the wrench that way, which keeps the tensioner pulley back. And to prevent the wrench from going side to side, it won't go this way because it's up against parts of the car, but it could go this way and slip off. So that's why I have this tied on here to keep it from slipping off. So doing this way, the tensioner pulley is under tension and it's way out of the way right now, getting access to the bolt. All right, let's get it off. At the bottom of the alternator, there is this connector right here. You have to squeeze the tabs to pull it out. And then below the alternator, there's this other connector right here. You want to get that off and just take this wire harness and gently put it off to the side, and now you have room to work. Okay, so the next step is underneath the vehicle. You need to, I'm on the passenger side now, turn the wheel out all the way to the right, and it'll let you get at the grommet that's right up here. I'll zoom out to show you where it is. And there's several other grommets. You want to take off half of the grommets that hold the retainer clips that hold this shield in place. This is what they look like. They're the standard type that when you go to install them, you need to push this in. But when you want to get them out, it helps to have a tool like this where you can get in behind there and pop it open like that. So anyway, get all those clips out, get the heat shield out of the way. So there's a 10mm bolt up there. You can't use a wrench to get at it. you'd first have to use a socket. This was corroded pretty badly, so I had to take my time with some penetrating fluid. Anyway, got that out. Bottom of the radiator towards the passenger side, there is another bolt right there in the center of the screen. And you don't actually have to take it out, you can just loosen it. There is a plug that needs to come out. So basically just squeeze the tab with your thumb and pull that off. And then you're done on the bottom of the car. Okay, so here we are up on the top. One other thing I didn't mention earlier is to gain a little bit of extra room, I moved this module, whatever it is, I don't know, ABS module, not sure, maybe it's the main computer. I just moved it off to the side a little bit and it just allowed me to get my hand in there. To get it out of there, there were two bolts. There was one bolt right there, and then there was another bolt right here, right behind the headlight. There's a 10mm bolt to come out of the radiator shroud there and there. And now it just lifts up and out. And to do this job a second time after all the corroded bolts were lubed up, it would be a breeze. Okay, so now we get a better view of the alternator. The top bolt is right here. It's a, I believe, 12 or 14 mil right here. And then at the bottom of the alternator on the passenger side looking this way, there's a 12 or 14 mil. One's 14, one's 12. And the bottom one is seized and I'm worried about breaking it off. So I got the radiator shroud out of here and I'm gonna spray some lubricant on the shreds of that bottom bolt and we'll see if it loosens it up. So this alternator has a rectifier and a regulator all built in. So what comes out of this is 12 volts. Now, here's the output terminal right here. And then of course, here's the chassis of the alternator. And what I have is my red lead from my meter connected to an alligator clip to that 12 volt terminal that comes out of the alternator. And then my black lead right to the chassis. So if you look here, I will connect and we have pretty low resistance between the positive terminal and the chassis. There should be basically open circuit. And then I know that in one direction, you're supposed to get some reading and in another direction, you're supposed to get infinite resistance. So we'll just switch this around. I don't know which is which. So let's see here. But in my case, I get, about the same couple of ohms in either polarity. Okay, now let's check the new one. So here's put the positive terminal on the 12 volt output. And we're getting 290 kilo ohms in this polarity, 287 kilo ohms. And we'll switch our leads back to the normal orientation. And now that the leads are switched back, in this direction, I get infinite resistance. So basically, when I take the positive lead of my voltmeter and connect it to the positive output of the alternator, and the negative lead of my voltmeter and go on the side of this, I should get, well, now I'm getting 14. I'm getting megs anyway, 16 mega ohms, so very high resistance. So basically we proved that alternator, the old one, is faulty. Now what's interesting is when you buy a remanufactured alternator, they charge you for the core, meaning they want the old one back. When I look at the old one, it's got a bunch of cracks in it. Crack there, cracked here as well. These cracks have been there for a long time, they're not fresh. And also here. So something has swollen inside to cause this to break like that. So it'll be interesting to see if I actually can get the core charged. Okay, we got the new alternator in there, down in the hole. It was kind of a snug fit to get it in between the bracket where the lower bolt goes through. But anyway, we got it and we got the belt back on, and can't say enough about how helpful that was to have that ratchet strap configured the way I've shown you so that you can basically work with both your hands while having the tensioner retracted back. Every time I put bolts back in, I wire wheel them if they're at all corroded so that they go in easy. I anti-seize them. And when you're putting electrical connectors back together, make sure you use some dielectric grease so that moisture doesn't get in there and cause corrosion and other intermittent problems. So yeah, that's where we are at this point. I'm going to be reattaching this component, putting the wire harness back in place, and then we'll give it a test. Okay, so we've got the alternator, all the wiring back together, the fan shroud in, the fan plugged in, and the only thing I have left to do is put the coolant overflow tank on, which I won't forget to do that. And I did charge the battery up with a battery charger, and when I started it up, it went from 12.5 to 14.2 volts. That's a perfect voltage for charging at an idle. And I'm going to shut the vehicle off now that I know the problem is resolved. Whenever you have a situation like this where the battery voltage has been very low, like 0 volts, 1 volt, 5 volts, all over the spectrum, a ton of trouble codes get set. So the last thing you do after you do a repair like this is go in and clear all the codes. So now that when you start the vehicle, you have the best chance of doing proper tests that are not influenced by the low battery voltage condition that had been going on before that. So that's the last part of this test. And now these codes are all cleared. We'll take the vehicle for a drive to see if any come back, but I would expect all the low voltage codes to be gone. You never really want your vehicle's alternator to charge a low battery when you're in a position to use a battery charger that plugged in. And the reason why back in the day, alternators used to be able to charge a battery from being completely flat to fully charged, but now with cheaper materials, trying to reduce weight, trying to reduce rotating mass and all that stuff, alternators do have a peak current rating of, like this one I think is 53 or 60 amps, but it's not continuous. It can't do that long enough to charge a battery. So I'll be topping this battery up using the wall plugged battery charger. And then in the morning, this one will be ready to go out the door. There are your steps for changing the alternator on a Honda or an Acura. Good luck with your do-it-yourself projects. If you like my videos, please